Hello, this is Arjan. I'm going to continue with the Chapter 4, Example 10. In order to start a project, let's hit a new project, make it plain. Let's call it Chapter 4, Example 10. And let's select the directory Chapter 4. Okay. The unit system is fine. We can next, add bin, finish. Now we are in the first page in the STAAD Pro. Let's face it to the front view. Close the grid because it's more comfortable to work with these tabs. Even you can, if you want, you can import your points coordinate system from Excel. So we have A, B, C, D, E. Our A is 0, 0, B is 6, 0, C is 16, 0, D is 20, 0, E is 24, 0. Then the next step is that we have to connect these nodes together. A to B, B, C, D, and E. Now if you want to see the values for the notation, display them, it's fine. The next step is that we have to go to the next General tab, define the materials. Since our unit system was keep and fit, we have to go to input units, make it inch, okay. Then the next step is that we have to go to the material, create a new material. Let's call it new. My material is 10,000 KSI. So I'm gonna select 10,000 KSI here and okay. The next step is that we have to go to the property, define a new property. We have two options, make it rectangle or make it a general property. We can find a rectangle with equivalent moment of inertia that is given in the problem statement. So the material is new. My moment of inertia is 4,000 inch to the power of 4, so it's going to be 48 here. 1 over 12 times 48 is going to be 4, it's going to be 10 inch. So the modulo of this is going to be the same, add, close. Then we have to assign this section to our members. So I'm going to assign it to member for 4 members. Now the next step is that we have to define the supports. It's a simply supported bin. We have roller and pin, create. We need a pin, add, and the next one we need a roller. I'm going to release these and add. So let's assign pin to node A and roller to the last node. The next step is that we have to define the loads. But remember, let's change the units from inch to feet in order to be more comfortable. Okay, then go load and definitions, load case details, add, close. We have a nodal load, 18 kips, downward, so it's going to be, we have also in nodal loads, we have 12 kip feet, it is counterclockwise, so it should be minus 12 kip feet, add. Then the next one is going to, we need the member loads, it is, the intensity is 2.4 kip feet downward, so it's minus 2.4. The first length is 6 feet. I'm going to add it, and the next one is going to be 10 feet. Then add it, close. Now we have to assign these to the nodes. If you want to see the nodes labels, node numbers. Okay, so 18 kip is going to be assigned to node number 4, node number 2 or B. Then we have these, my 12 kip feet assigned to node number 4. We have minus 2.4 kip per feet assigned to first member, and this one to second member. If you want to change the scales, if you don't like it, you can do the scale, apply immediately. Point force, we need it a little smaller, so the scale should be larger. The same with point moment, we need it a little smaller. Okay. If you want to see the values, right click labels, load values, okay. You see, the values are correct. The next step is that we have to analyze this problem. Analyze, analysis print, add an analysis type, then go to analyze, run analysis, save, done. The warning is that because we only defined one parameter for the material, we only defined modulus of elasticity, we left the other one empty. Now let's see the results. We can go to post-processing, okay, see the displacement. This green is the deflected shape. We can make it a little more exaggerated, go apply immediately, make the displacement scale, make it smaller to be larger. Correct? If you want to see the values, we don't want to see this, so we can go results, view values, nodes, I need global Y, and beam results, I need the bending and shear, and let's also get the maximum displacement, annotate, close. Now we see the displacement in each member. If you want to see, and if we can compare it with our hunch calculation, and they are very close, the result of deflection with hand calculation. Also, we also see the radian, the rotation for each node. If you want to change the accuracy, you can come here, go to the force units, rotation, make the decimals to the 5, okay. Then you can compare it with your book. It's really important that you are able to compare your results with your hand calculation. And also the beam, you can change the scale here. Let's go and change it. Moment, bending Z, apply immediately, make it smaller, okay. Also you can see the values. View values, beam results. Close. So it is your moment, and also if you want your shear, it is your shear. I hope you enjoyed this. Thank you so much. See you in the next one. Bye.